We are here live. Okay. Okay. Hello. 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 Are we here? Are we here? Are we here? Good morning. Good morning. Once and again, you are welcome. Good morning. Once and again, you are welcome. This is University on the Niger. We are live from University on the Niger. Okay. Okay, so I can see, please just activate your friends, call them, let them come online. Let them come online, let them come online, okay? In the next 1 minute, I'll be starting the course. Just for the few minutes, we'll just take off the few minutes, we just have few minutes for the class. I can see Samachi Miracle, that's nursing science. I can see Ndobo Ako, Treasure, Amarachi, nursing. I can see Onu Zulike Chinwendu Divine Radiography. I can see Francis Ifani Radiography. Okay, so please, I just have a few seconds before I begin the class. I hope we are here. Please use your your chat section, use it, to write one or two things as I begin. In case you have question, you direct the question. Okay, blessing on Nigeria. I can see you, nursing science. I can see marvelous or Howard. Okay, Madam Surge, Elizabeth, or Lucy. Nursing science. Yeah, okay. So we are good to go. Okay, we are good to go. Hello, we are good to go. We are good to go. I hope you are keeping well, you and your family. Let's start. Wow. Okay. Glory be to the name of Jesus. Okay, so let's start. Now, the other time we started with what's it called? Newton's laws of motion. Newton's laws of motion, and I started by defining what motion is, and also the first law of motion. I also defined again, I gave us what inertial frame of reference is, and then from there we took off to Newton's second law of motion. Now, and from there I proved a lot of things for you, and we concluded by solving a lot of questions. We did example 1, we did example 2, okay? So, and from there, we'll take off again. I gave you guys assignment. Make sure you are working on those assignments, okay? Now, I want us to look at example 3 today. Example 3 today. Now, let's look at example 3. Please make sure you are with your writing materials, your notepad, your notes, your pen. Please write them. Just get ready. We need to solve some things now. So please, example 3. Now, a body of 0.6 kg of mass. So a body of 0.6 kg of mass is pushed. So a body of 0.6 kg of mass is pushed along a tarmac through an acceleration of 2 meters per square second. Calculate the mass of the second body whose acceleration is 4 meters per square second. Let me take the question again. I said a 0.6 kg of a body, a 0.6 kg of a body is pushed along a tarmac through an acceleration of 2 meter per square second. Calculate the mass of the second body whose acceleration is 4 meter per square second. So now let's look at the calculation itself. Let's look at the calculation. Let's look at the calculation. So please just focus. So I said that a 0.6 kg of mass is pushed along a tarmac through an acceleration of 2 meter per square second. Calculate the mass of the second body whose acceleration is 4 meter per square second. So let's look at the calculation. So now let's look at it. Let's look at it. Let's look at it, okay? Okay. Let's look at these things. Oh, what's happening here? What's happening? Okay, so let's do the calculation. Now we have our M1, okay, divided by M2 equals to A2 divided by A1. Now this is the formula, okay? So now, but we are given from the question that M1 is equals to 0.6 kg, okay? Then M2 is what you are asked to get. Now we have the first acceleration. So the first acceleration is 2 meter per square seconds. Then we have the second acceleration. The second acceleration to be 4 meter per square second. So now let's solve. Okay, so let's look at it. So the first mass, which is the M1, is 0.6. Now divided by the M2. We are looking for the M2. So which is equals to 4, that is A2, divided by the A1, 2 meter per square seconds. Okay, so now from there, because we are searching for the M2, which is the mass 2 of that same body, we need to clear the fraction. So that is now 0.6 times 2 equals 4 times the M2. Now, we are looking for the M2. We have to divide both sides by 4. We have to divide here also by 4. So, and when you cancel out the 4 from this side, you cancel out the 4. Now, we are now left with M2 to be equals to, this is our M2 to be equals to, now 0.6 times 2 divided by 4 will then give us 0.3 kilogram. Okay, so So now you see the value. Okay, let me just adjust something so we can have the full details. Can have the full details. So you can see, you can see. So we have the mass one, then that's the formula. M1 over M2 equals to A2 over A1. Okay? Now we have our M1, we have our M2, we are looking for the M2. So after the whole thing, yeah, so you have to understand that you insert the value of M1, that is 0.6, then divided by the M2. We are looking for the M2. Now equals the A2 is 4 meter per square second divided by the A1. The value of the A1 is 2. Now when you clear the fraction, okay, so this is 0.6 multiplying 2 equals to 4 times the M2. Okay, then we have to divide both sides by 4. Then you get this your 0.3 mass. That is M2. M2. I believe we are together. We are together. It's very easy. It's very easy. Okay, now I want to give just a little, something to play with. Just when you get after the lecture, just play with it. Play with it. It's going to help you. Let's look at a classical example again. Something that you need to play with. Play with it in your house after the lecture. Okay, so now let's look at another case scenario where we have a body of 8 kilogram, a body 8 kilogram of mass, a body 8 kilogram of mass. Please copy this. So copy. I hope you are following. 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 Okay. So we have a body of mass 8 kilogram, a body of mass 8 kilogram. So that 8 kilogram of mass is pushed along a tarmac through an acceleration of 0.2 meter per square seconds. Let me take it again. A body of mass 8 kilogram is pushed along a tarmac through an acceleration of 0.2 meter per square second. Calculate the acceleration of the body whose mass is 4 kilograms. Are we together? Calculate the acceleration of that same body whose mass is 4 kilograms. Please play with this, it's going to help you. Play with it, it's going to help you. Now let's look at a second question. Now, second something. Okay, let's look at second question. Second question. Now, this question is question 2. Question 2. So this question is question 2. So example 2.0 again. Example 2.0 again. Okay. So now example 2.0. Okay. This is example 2.0 now. So example 2.0. Okay. So now let's look at another situation where we have, please copy this question. That's another example. A 25 kilogram mass acted, a 25 kilogram mass of a body acted by a constant force for 2 minutes. A 25 kilogram mass acted on a body by a constant force for 2 minutes. Now it increases its speed by 400 meters per second. It increases its speed by 400 meters per second. What is the magnitude of the force in the direction of motion? So what is the magnitude of the force in the direction of motion. So what is the magnitude of the force? Okay, so let's look at something. So we have from the question, we have that our time, the time, the time is 2 minutes. Now when you convert 2 minutes to seconds, that is 2 times 60 seconds, which will give us 120 seconds. Okay? Now we have our increase in the speed. The increase in the speed, which is the same as V minus U, equals to 400 meter per second. So 400 meter per second, okay? 400 meter per second. Now we are now asked to calculate the magnitude of what? The force. So we are given the mass, to be 25 kilogram. Okay, so now let's get, we all know that the formula of force is F equals to MA. Okay, F equals to what? MA. Okay, are we there? Now, but we need to get our acceleration. So A acceleration, which is V minus U all over what? T. So our acceleration is then equals to, so our V minus U, which is 400 meter per second divided by 120. So you cancel out. When you divide this to get our acceleration, we are going to have 3.33 meter per square seconds. Okay? Now from there, we need to get the magnitude of the force. So the magnitude of the force, which is F, equals to MA. So and our mass, which is 25 times 3.33, which is equals to 83.25 Newton. This is our final answer. This is our final answer. Are we following this? Are we following? Are we following? Are we following? Are we following? I hope we are getting this. I hope we are getting it. I hope we are getting it. I hope we are getting it. I hope we are getting this. I hope we are getting it. Okay. 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 So I want to teach the final law of Newton. The final law of Newton. The final law of Newton. Please, any reaction, you have any question, you ask your question. Ask your question, ask your question. Okay, ask your question. Okay, so now, the final law, which is called Newton's third law. Newton's third law of motion. Newton's third law of motion. Newton's third law of motion. So Newton's third law of motion. That Newton's third law of motion states, Newton's third law of motion states that the action and reaction are equal and opposite. I will show you now mathematically that the action, whether of any object or of a body, action and reaction are equal and opposite. I believe this is the one that you know from your secondary school, just like we did last week. Just like we did last week. Now, let's look at something again, because now you are in year 1. You need to understand something. I want to show you something now. I want to show you guys something, okay? So, I want to show you guys something. We are looking at Newton's third law. And that law states now that to every action there is an equal and opposite reaction. To every action, there is equal and opposite reaction. I want to show you guys something. Please look at it. At every point in time that you state this, you must show us that F subscript A is equals to minus F subscript B. So that is F subscript A is now the action force. F subscript A is the action force. Then F subscript B is the reaction force. So that is, to every action, there is an equal and opposite reaction. And this mathematical representation shows us this very, very well. Are we together? Are we together? Okay, so that is that for the Newton's third law of motion. Let's look at impulse and momentum. Impulse and momentum. Impulse and momentum. Impulse and momentum. Now, let me start by introducing momentum. Let me start by introducing momentum. So, momentum is denoted with just a letter called P. And therefore, it has a formula P equals to mv. Now, momentum of a body is defined as the product of mass and its velocity. Momentum is the product of mass and its velocity. Momentum is the product of mass and its velocity. Now, that is just the definition of momentum. And then momentum is a vector quantity. Momentum is a vector quantity. Now, taken from there, you know that the SI unit of mass is kilogram, the SI unit of velocity is meter per second. So that means the SI unit of momentum is kilogram meter per second. Kilogram meter per second. Kilogram meter per second. Now, let's look at a classical example, and this will be the place I will close for today. This is the place I will close for today. Okay, so now let's look at a classical example. A body of mass, 3 kilogram. So a body of mass, 3 kilogram. So the mass is 3 kg. So a body of mass 3 kilogram moves with a velocity. So that means the velocity, cancel this. The velocity is 10 meter per second. So therefore, we are now asked to calculate the momentum. So to get the momentum is now P equals mv, where our m is what? 3 times 10, which is equals to what? 30 kilogram meter per second. 30 kilogram meter per second. 30 kilogram meter per second. So 30 kilogram meter per second. 30 kilogram meter per second. Now I want to give you guys, something to play with at home. Just play with this, okay? Let's look at it. Now, a body of mass, 12 kilogram, moves with a momentum of 60 kilogram meter per second. A body of mass, 12 kilogram, moves with a momentum of 60 kilogram meter per second. Calculate the velocity of that body. Calculate the velocity of the body. Calculate the velocity of the body. Are we together? Calculate the velocity of the body. So please, I want to encourage you as you do this, you 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 do this, you then have to what's it called? Solve it. Please solve it somewhere in your notes. Make sure you get the right answer, and then you can solve as many as possible. You can get from any physics textbook. Solve, master them. They are very important. You need it. Okay. Now, please prepare for your mid semester. It's coming up soon. Then again, for I saw a lot of you we are using what's it called, the physics, practical physics table. I saw it mostly in radiography department. Please, those tables, they are wrong. I can't, I don't understand that table. Why I'm saying it is so that you'll avoid failure. Please get the right table and plot and write the table of reading. Write it in a manner that it has to look like physics table. The one I saw doesn't look like it. And then plot your graph very, very well. Thank you, and make sure you are keeping well. God bless you. Okay, that is that for now. That is that for now. Okay? Okay, thank you.